As discussed, let's now study about a simple pendulum. As shown in the figure here, a simple pendulum consists of a small metal bob which is attached to one end of a string. The other end of the string is attached to a fixed support so that the bob can be suspended freely in the air. When the bob of a simple pendulum is at position O, that is its equilibrium position, the net force is 0 Newton because the tension in the string cancels the effect of the weight, mass m multiplied by acceleration due to gravity g. But when we bring the bob at position A and leave it freely, it will start vibrating around the mean position O. This is because now the weight mg of the bob is making an angle theta with the string. If we recall our knowledge about the breaking down force acting at an angle theta into its components, we can write it as mass m multiplied by acceleration due to gravity g multiplied by cosine of angle theta and mass m multiplied by acceleration due to gravity g multiplied by sine of the angle theta mg cos theta and mg sin theta as shown in the figure. Here, the effect of mg cos theta is cancelled by the tension force in the string, while mg sin theta is the component which is responsible for the motion and acting as a restoring force. Due to this force, the bob starts moving towards its mean position O. At O, the bob is at its maximum velocity and due to inertia, it does not stop at O, but continues to move towards the extreme position B. While moving towards B, the velocity of the bob decreases due to the restoring force and becomes 0 when it reaches B. The restoring force is still acting on the bob and pulls it back to the mean position O. In this way, the bob continues its to and fro motion about the mean position. Here, a point to notice is that the restoring force depends on the displacement from the mean position and is always directed towards the mean position. That is why we consider this motion as simple harmonic motion. One of the most important aspects of a simple pendulum is its time period, denoted by t, which is simply t equals to 2 multiplied by pi multiplied by whole under root L upon g. L being the length of the pendulum string.